It's time for everyone's favorite kind of algebra problem, word problems. Yeah. But as you'll see, word problems don't actually have to be that bad. All right, so the first inequality word problem for today is about Bob the Builder. So Bob the Builder earns $100 for each building he builds, plus $20 for each room the building has. What is the least number of rooms a building needs for Bob to earn at least $300 from a building? So the first step of these kinds of word problems is to write out an equation or an inequality that represents this so that we can actually do math with it. So first of all, I'm noticing the different numbers we have in here. He earns $100 for each building, and that's $100 no matter what, right? Plus $20. So we already have the word plus, that means addition, and $20 for each room the building has. And he wants to earn $300. That's like the target amount. So on the left side of this inequality, we're going to go ahead and write how much he makes for each building. So in this case, he gets $100 no matter what, right? But he also gets plus $20 for each room the building has. Well, in this case, we don't have a specific building. We don't know how many rooms the building has. That's actually what we have to find out. The least number of rooms that the building needs. So that's going to be our unknown amount. So we're going to put plus 20 because he earns plus 20 for each room. So if he earns $20 for each room, then that means we need to multiply 20 by the amount of rooms. So you can use any letter for this. We'll just use the letter R for rooms because why not? Then on the other side, we need to put his goal. How much money does he want to get from this building? In this case, it's $300. We need to figure out what sign to put here. In this case, I'm seeing at least $300. What sign do you think we would put for at least? Well, first of all, I know that this would be greater than because he wants to earn more than $300, not less than $300. But do you think 300 is also included in this? Yes, because if he earns exactly $300, then he'll be happy he earned at least $300. So this isn't just greater than, we also have to put the line underneath, which means or equal to. If he earns exactly $300, he'll be happy. If he earns more than $300, he'll also be happy. So now we have ourselves an inequality that we can solve using our normal math stuff. So we need to get R, the variable, by itself. So the way we do that is by getting rid of this 100 first. We don't want to get rid of the 20 yet because that's more attached to the R. It's easiest for us to get the 100 out first. So we're going to go ahead and subtract 100 from both sides because that will cancel these out. And on this side, we're just left with 20R. But we have to do the same thing on the other side. So we're going to subtract 100 from the other side of the equation as well. 300 minus 100 is 200, and we'll just carry the sign down. So now we just have a one-step inequality. 20R is greater than or equal to 200. So to get rid of this 20, remember this is being multiplied because whenever there's not a sign and they're just next to each other, that's multiplication. We need to do the opposite of multiplication, which is division. We're going to divide both sides by 20. On the left side, we're just left with R, and that is greater than or equal to 200 divided by 20, which is 10. So in this case, R is greater than or equal to 10. So what does this answer mean? Well, R is the amount of rooms, right? So in other words, if a building has greater than or equal to 10 rooms, then Bob the Builder will earn at least $300 from this building. So the question's asking, what is the least number of rooms the building needs? Well, 10 rooms. So the answer to this problem is 10 rooms. All right, here's another example problem. What I'd like you to do is go ahead and pause the video and try this one out for yourself. All right, so Mrs. Teacher is trying to manage the behavior of her kindergarten class. Whenever a student misbehaves, Mrs. Teacher gives them 5 sad face points. A student will have to go to the principal's office if they reach 30 points. How many times can Jeffrey, one of Mrs. Teacher's students, misbehave without having to see the principal? Well, let's write an inequality to represent this situation. The numbers I'm seeing here is 5 points for each time the student misbehaves. And we also have the number 30 here, which represents the total amount of points that a student doesn't want to reach. So on the left side, we'll put 5 times the amount of times that a student misbehaves. We'll go ahead and put M for misbehaviors. I don't know. and then we're going to put 30 because that's the total amount of points that a student doesn't want to receive. So in this case, would you say we would use less than or greater than? Well, I think they would use less than because they don't want to reach 30 points. As long as you have less than 30, you're fine. You don't have to go to the principal's office. So we're going to go ahead and say that 5M needs to be less than 30. But will we put a line under this? We actually wouldn't in this case, because if a student reaches exactly 30 points, well, they have to go see the principal, and they don't want to do that. So the number 30 is not acceptable here. It needs to be less than 30. So let's go ahead and solve this inequality. In this case, it's actually only one step. We need to get m by itself, so we're going to divide both sides by 5, because that is the opposite of multiplication. The 5's cancel out, and we're just left with m on the left side. The sign stays. And on the right side, we have 30 divided by 5, which is 6. So the final answer of this inequality is m is less than 6. But what does that mean in the context of this problem? The question's asking how many times can Jeffrey misbehave without having to see the principal? Well, can he misbehave 6 times? No, because 6 is not included in this. And since you can't misbehave a half of a time, the maximum amount of times that he can misbehave is 5. And if he misbehaves any less amount of times, then that's fine. So if you wanted to write this out as an answer, you could say that he can misbehave 5 or less times, because 6 doesn't count. Here's a more businessy type of problem. Go ahead and pause the video and see if you can solve it yourself. Alright, so Susan is selling a plushie on her website. She earns $2 on each sale plus $50 per week. What is the least amount of plushies that Susan needs to sell this week to make at least $200? Well, I see 2 ways that Susan's making money. First of all, she earns $2 on each sale. So that's probably going to be 2 times, a letter like before. She also earns $50 per week. So $50 flat. And right here, I'm seeing least amount of plushies. That's probably going to inform us of what kind of sign we need to use. And then her goal is to make $200. That'll probably go on the other side of the equation. So let's go ahead and write this as an inequality. $2 on each sale. So we're going to put the number 2 times however many sales she has, which we don't know yet. That's what we're trying to find out. So we'll just put the letter S for sales. She also earns $50 per week, and that 50 stays the same every week. So we're just going to put 50. And on the other side, we're going to have 200 because that's her goal. Now, does she want to make more or less than $200? Probably more. So we're going to put the greater than sign because we want the amount of money that she makes to be bigger than 200. Now, do we put a line underneath this greater than sign or no? Well, she wants to make at least $200. So if she made exactly $200, yes, that counts. So we will put a line underneath this greater than sign because 200 is included in the amount of money that Susan can make to reach her goal. So now we have a 2-step inequality right here. We want to get rid of this 50 first, right? Because this 2 is being multiplied by s. We want to get rid of the one that's not attached to the s first. So we're going to go ahead and subtract 50 from both sides. These cancel. And on the left side, we're just left with 2s. On the right side, we have to do the same thing. So we're going to subtract 50 from the right side as well. 200 minus 50 is 150, and the sign stays the same. So now we just need to get rid of this 2, and it's being multiplied by s, so we need to do the opposite of multiplication. We will divide by 2. These cancel, and we're just left with s. On the other side, we need to do the same thing. So we're going to divide 2 on the other side. 150 divided by 2 is 75. And if you didn't know that, you can just put that into a calculator. And we'll just put the sign back here. And that's our answer. S is greater than or equal to 75. However, what does that mean in the context of a problem? Well, the question's asking, what is the least amount of plushies that Susan needs to sell this week? Well, S is the amount of sales, or the amount of plushies. We could have used the letter P for plushies, it doesn't matter. But in this case, this is saying that she needs to either sell more than 75 plushies or exactly 75 plushies. So if we wanted to word out this answer, we would just say 75 or more plushies. And that's our answer. So I hope this video shows you that inequality word problems don't have to be that bad. You just need to make sure that you're looking for each of those numbers in the problem because they're probably important, as well as the keywords like at least or no more than, because those will probably tell you what kind of sign you need to use for the problem. And then you just solve it like a normal inequality that's not a word problem. If you're still struggling a little bit on the math side of inequalities, that's totally fine. I actually have a whole nother video on solving inequalities, which you can watch right here. And as always, you can leave a comment if you're confused about anything, and I'll be happy to help. Thanks for watching.